Worries.
Background noise. All right.
All right.
Tally ho.
All right. We are live, and we are live for Meetup, not 61, 62, 63, 64, but Meetup 66. And not only that, but geographically speaking, I'm very happy to be doing a Meetup from California, from the Bay Area, with somebody else who is also in the Bay Area. We'll get to him in a second. As usual, this is Data on Kubernetes community. If you're not following us on Twitter and LinkedIn, come on, get on there. It's really easy to do. Jump in our Slack, ask questions. Big announcement this week. We've got 2 interns who are going to be working with us. There will be some more that'll be coming in. We've got Kunal and we've got Vanchika who are going to be helping us out with all different things, dynamizing our community, interacting, engaging more with young people, getting those resources out there so that the onboarding process of getting started with data on Kubernetes is a little bit easier. And speaking of that, someone who has spoken more than twice about data on Kubernetes, very happy to have Robert Hodges with us, who is the CEO of Altinity. And he is located, I believe, in Berkeley. You'll correct me on that in a second if I'm not right about that. But Robert, how are you doing today?
I'm doing great. I'm delighted to be here to talk about Kubernetes and ClickHouse.
Good stuff. And you are a Bay Area native, is that correct?
That's absolutely right. So you were right about Berkeley. That's North Berkeley on the wall behind me. That's a real bookshelf, by the way. It's not one of these Zoom facades.
This is a real bookshelf to my left as well.
Yeah, exactly.
For what it's worth. That's refreshing, and you got a lot of good stuff on there. And one of the things that you may have noticed in the tweets leading up to this is that Robert's Twitter handle is DB Cicero. And so we were talking about this before we got started, is that I started college as a classics major, ended up transitioning to a bunch of different things and finished with religious studies. That's another topic for another day. But where did your interest in classics literature history come from, Robert?
It was something I picked up when I was a kid. We had in 8th grade, my school had a Latin class. I took it. I just thought it was something fun to do and just stuck with it. It turned out that there's just some incredibly stuff that you can read. And so, for example, Cicero wrote letters where he talks about, where he's exchanging letters with the people who assassinated Caesar, and they're describing how they went over and had dinner with Mark Antony, and Mark Antony would say, "Hey, I can't guarantee your safety here in town tonight." Stuff like that is just unbelievably cool. And Latin, opens up this, and classics opens up this window into this world that people normally don't see.
Yeah. And with that in mind as well, too, specifically on the topic of Cicero, in terms of, I think in his lifetime, unfortunately, there's a lot of texts that we don't have access to or that have disappeared over the years. He was by far one of the most prolific writers. And I think that's interesting as someone, who's had a career in data. You're pretty prolific as well, right?
Not like Cicero, and certainly not as good. I think he was, not only was he prolific, but he was extremely good. So all of his stuff, a really big chunk of his stuff got preserved, like his letters, but then all his speeches, and he was amazing. I think it's been, I really recommend reading him, particularly if you do talks, because he was a good talker and knew how to figure out how to entertain and educate and persuade audiences.
I think that's a great point. And also nowadays when we live in the, content is king, and we go back, oratory was king and still has its relevance in many, many senses. I think a lot of it, as much as people say, oh, Latin is a dead language, or these things happened a long time ago. If you start taking away the dates and you maybe forget about some of the other factors, still dealing with similar problems in terms of.
Absolutely.
Right? Like, we're just not rocking tunics, I guess. Maybe
and I'll give you an example. So I run a company. We have a couple advisors that I just worship the ground they work on. They, like, one of them I'm not very good at doing certain kinds of slide presentations. So I was talking to my advisor. He started explaining what to do using Greek, terms from Greek rhetoric. I mean, this is stuff that's like 2,500 years old. It's still relevant today.
And how could it not be more relevant when we're talking about Kubernetes, which comes from Greek?
Greek, exactly.
This couldn't be a better example.
Yeah.
That being said, can we just get a little bit of background about how you got into working with data?
Yeah. I was in the Air Force back in the 80s, and I ended up working with a database called M204, which was something they just brought in. This was starting in 1993. It was a pre-relational database used by a lot of U.S. government. And I was fascinated by it. It was the coolest piece of software I'd ever used. When I got out, I really wanted to go work with them. I ended up going and studying at the University of Washington instead. But then I got a job at Sybase in 1990, and so that was really what launched me on doing sort of industrial data. And that was kind of like working there was like doing a master's in CS. It was just really, really great. And I've stuck with it ever since.
Good. And thinking about that as well, too, because we talk a lot about databases. We've had multiple talks about Postgres. Being in Berkeley, and the sort of birthplace of this database has been so widely used, so battle tested. What do you think it is about the conditions in the Bay Area that have made it so ripe for things like Postgres to be born here?
Well, I think that the UC Berkeley had a lot to do with that. There's just like a really, really outstanding academic core that's works with databases. So Sybase was developed there. Obviously, Mike Stonebreaker was on the faculty there. That's where he was the initiator for Postgres, and then a whole slew of companies that came out of that. Ingest is another one that came out of the Bay Area. There's just like this core of expertise, and it sort of feeds on itself. Like we used to at one point, we were all like sort of going around tracking each other as we move from one firm to another. So you get this nexus of people who understand it and kind of feed on each other, do new things. I think that's why you see so much stuff here.
Very good. Without further ado, we can jump into your presentation. Just a quick reminder to the audience, Robert has said that if anybody has questions, put them in the YouTube chat. We will address them on the spot, so we won't leave them towards the end. But like I said, feel free to start sharing your screen. Let's jump right in. And
I'm going to roll.
Today's a little bit risky, right? Because we're doing this on a Linux laptop, you said?
We're doing this on a Linux laptop. So, if it kind of, and an old one too, it's an old Dell. All right. So can you see my screen? I'm going to just go ahead and pop it up into full screen. All right. Oh. Huh. Interesting. Just 1 second. I'm going to stop the share.
It's all good.
Like that was weird.
Not a problem.
I see what happened. I actually hit the annotate button accidentally. All right. So you can see my full slides. All right. Yes. I'm going to be talking about high performance app analytics using ClickHouse and on Kubernetes. And I'm going to explain what all those terms mean. But I also have a couple demos, and let's dive in. So we've already talked a little bit about my background. Started working databases in 1983. I've worked with about 20 of them. ClickHouse is around number 20. And it's sort of like some of them, I worked with like DB2. I worked with one literally for one day, just long enough to realize I hated it. And then there are others like MySQL where I worked with it for 10 years. Sybase for a really long time as well. So I've also been using Kubernetes since 2018. I was my last company we sold to VMware, so I went and lived there for about 4 years, and that's where I got introduced to Kubernetes, and it's been a big part of what I've been working on since then.
And with that in mind as well too, just going back to 2018, when was the first time that you really kind of encountered this stateless versus stateful debate?
How do you mean that? Because that's sort of been going on for a really long time.
Yeah, I'm just saying within the context of Kubernetes.
Oh, well, yeah, I can tell you because when I took this job, I had a talk with a couple of the guys on a couple of the investors, and we were sitting in San Francisco, and we were having a big argument about whether it made sense to commit the company to building stuff on Kubernetes. And I have to admit, I was kind of skeptical, because this was back in 2018 at a time when storage was just reaching the point where it kind of worked, and where you could trust it. I think that has really changed. We run a cloud service. In fact, that's my company, Altinity. We're a provider for ClickHouse, this very popular columnar data store, and we run all our cloud stuff on Kubernetes, and it's definitely been a great choice. But I think if you're in distributed system, I didn't think of it as a stateful versus stateless debate, because if you come from a distributed background, you're always thinking about that. That's something that's been really big in distributed systems for decades.
Okay. We already got a question from someone in the audience. Hi all, we have implemented ClickHouse Operator on Kubernetes. Is there a way to automate backups on this?
That's a great question. Yeah, we put them use ClickHouse we use ClickHouse Backup, and we put it in a container, in its own container, and run it as a sidecar. So that's the way we do it. That's a great question. I think what we probably want to do is, it's kind of hard to answer that one in depth, but ClickHouse Backup is the answer. I think what I'll do is I'm making some notes for blog articles, but that's definitely one to look at.
All
Good
right.
to know we have a user out there. Thank you.
Yes.
All right. Let's talk about what are application analytics. I want to give you a little bit of, by the way, how many people do we have out there on YouTube?
Right. So far, we've got about 30.
30. Okay, excellent. So I'm assuming there's some people who are beginners, and this is going to level set a little bit and also teach you a bit about ClickHouse and how it fits in. So it's simplest to start this with just looking at a concrete problem. And for a lot of people on this call, you've probably seen this screen. This is Google Analytics. Now, this does not actually run on ClickHouse, but there's a bunch of other products that do the same thing, that are basically measuring visits to websites and all the interesting statistics related to them. And they run on ClickHouse. So for example, if you use Cloudflare and you look at their web analytics, they're actually driven by ClickHouse underneath. What's interesting about this kind of problem, specifically web analytics, is people want to look at data and measurements associated with things like website visits, and they want to do it in a very flexible way. So for example, you'll come in, and this is the, when you're looking at, checking out, hey, what's the, rate of visits on my pages, you're going to look at things like, hey, number of page views, unique page views, so on and so forth, bounce rate. And then you're also going to be able to drill down into alternative dimensions. You're going to be able to change the time that is, the time range that you're looking at. These are all things that change the query dynamically and increase the scale or scope of things you're looking at, choose different things to add in, take things out, so on and so forth.
Okay, we got another question. Sorry. Another from the same person as the previous one.
Yeah.
Another thing for us to know would be, what is the storage type that is recommended for storage class on Kubernetes for ClickHouse? Block storage or file storage? Azure file storage seems very.
Yeah, hold on that. I'm going to get to, I'll get to those when I get into.
Good.
In fact, for these, for that question, that one might be a good one to hold till after. I can definitely comment on it. Okay, so online analytic processing is what we call this kind of database problem. And basically what we're doing is it's really reading it. To answer this effectively, you need to be able to read enormous amounts of data, and we organize it into what are called dimensions. So things that are properties, in this case of a website visit, like what's the page, what's the landing page that we arrived at, what's the medium we came through, what's the source, referrer, all that kind of stuff. And then also time tends to be really important in this as a way of characterizing it. And then we have metrics. So we're gonna do, for on 9/14, like how many people hit the root page. So these are things that, and in order to solve this, you have to have a database that is optimized to read enormous amounts of data very, very quickly, and to do it in ways that are unpredictable. So for example, I could just suddenly say, hey, I want to see that I've got the page, but I also want to see break this out by medium, and then see page views. And by the way, I don't want to see, I'm not so interested in days. I'd like to see this by hour, and I'd like to see this from Tuesday to Wednesday. This is things that just kills ordinary databases, especially because the amount of data you're dealing with can be huge. It's often trillions of rows. And so you need to be able to get in there, and you sometimes need to ask questions where you might have to scan every single row. An ordinary database like Postgres, which we're talking about, just can't handle this. The data isn't organized right. It cannot parallelize sufficiently. It doesn't have the ability to scale and use the resources of many machines. So what kind of database would do this? Well, data warehouses are designed to do exactly this to solve exactly this kind of problem. And ClickHouse is, without being too, bragging too much, ClickHouse is really the first open source data warehouse that talks SQL and can play with the big kids. So you think about Snowflake, you think about Redshift, you think about Vertica, all these proprietary databases. ClickHouse can actually match their performance, and in some ways actually go considerably better. So here's just a few things about it that are important to know. One is it understands SQL. So this is, and in data warehouses, you pretty much have to do this because all the tools need to do it. It's very portable. It runs anywhere that Linux does. It will literally run on an Android phone. There's an article on the ClickHouse website about this. All the way to racked equipment, and then it runs great in containers, it runs well in VMs, so on and so forth. It organizes data in columns. This is one of the key, and those columns are compressed. And this is why it can do these, one of the reasons why it can do these queries so quickly, because we don't have to read a lot of stuff. It's also very good at parallelizing the reads. So both spreading across a bunch of nodes, as well as parallelizing it within the scope of a single CPU. So for example, breaking the arrays down into pieces, farming them out onto all the cores, using what are called SIMD instructions, single instruction, multiple data, to be able to to do mathematical operations very quickly on the CPU using specialized registers. It has built-in sharding and replication, unlike a database like Postgres, which is, you get one database. Yes, you have, for example, primary, secondary replication, so you can make read-only copies, but it doesn't naturally scale. ClickHouse has the scaling tools built in so that you can actually spread your data over hundreds of nodes. And as a result, if you design it, if you use it the way it's meant to be used, you can get linear scaling of your queries out to 10, 10, 20, 30 petabytes of data just by adding more resources. It's also open source, which is really significant, and the license is very flexible. And then the final thing is it's incredibly fast. And that's what kind of grabs people by the collar. The portability and the fact that it's easy to access are also, those are more valuable things over long term, but the fact that it's really quick is a thing that people are interested in. And rather than bore you with more details about how it got quick, I'm just going to show you an example. So let me just go ahead and I hope this is visible. I'm going to just run a really simple demo that shows how quick these kinds of data warehouses can be. What I'm pointed to is actually a ClickHouse data warehouse. It's a single node running on Kubernetes. And I'm going to go ahead and run what's called a count. So if you know SQL, I'm going to just go ahead and run this count, and it's taxi data that I'm looking at here. This is a well-known data set. There's 1.3 billion rows. These counts are really fast. That's not, though, what I'm not trying to demonstrate that we can count things quickly, because any database can do that. What I want to do is I'm actually going to do a query where I'm going to take the average of 1.3 billion numbers generated in memory, and we're going to see how fast that is. So here we go. There's a magic table we can read from. We're going to generate 1.3 billion numbers. Oops, what have we got here? Hang on one second. Oh, here. Forgot to cancel out the old thing. We run this, bang, in 6/100ths of a second, or about 0.6 seconds, we get a result. That's kind of fast, but not really. And we've run it a few times. It bounces around, so it looks fairly stable. Let's run against the real data. So this query was doing everything in memory. Now I'm actually going to go out to storage. And to answer that question that came up before, this is going to be hitting persistent volumes that are on Amazon GP2 storage. So it's block storage. You'd think we got to hop over the network. How fast is it going to be to run this average? We're going to run it, and bang, what we see is it runs in 0.128 seconds. So this is about 5 times faster than doing everything directly in memory, even though we went out to storage. And the trick here is that we were actually, and let's see if it bounces around a little bit. Okay, it looks like the caches were hot. So it's it will actually, if the caches are cold, it'll run at about 200 milliseconds. But the point is, it's faster than doing stuff in memory, even though we have to go get all that data off EBS. The fact is, though, we didn't get very much because the data is highly compressed. So, and we also parallelize really well. Okay, well, we can do this in-memory count a better way. So the reason that we're faster than being in memory is because that particular query didn't parallelize well. And so even though we're in memory and only using the CPU, we were kind of slow. So let's cheat a little bit less, and let's actually run the average using another number generator that parallelizes better. So this is another table which generates the numbers, but it knows how to do it in a multi-threaded way. We run this query, and this is a lot faster. This is down to 0.082 seconds. So it's starting to get pretty quick. And it's about something like a third faster than running from storage. And we run it a couple of times, and you can see it's fairly standard. So, or fairly stable times. So the thing is, though, that ClickHouse can actually get a lot faster by optimizing these queries and doing a little bit of work ahead of time in what's called a materialized view, we can make ClickHouse way faster than this. And so what we're going to do is we're going to go against this materialized view, which pre-aggregates the data. We're going to run that query. It gets exactly the same result, but it's so fast that it's less than a millisecond. So it actually comes back showing it processes in 0 milliseconds. This is so fast that it can be used to, and ClickHouse is often used to do things like answer questions while somebody is trolling through a web page to decide what to show them, to tell them, for example, to turn their ad blocker off. This is all done on Kubernetes. So that's the demo. What I want to do now is talk a little bit about how this is actually used in real life. So how you can do this, and then we'll step into how to build it on Kubernetes. So one of the things that Kubernetes and ClickHouse together can enable is to do what we call in-app analytics. And they have it, there's kind of a pattern to them that this shows that you have in the center, you have what we call a low latency analytic database. That just means a data warehouse that can answer questions really quickly. We also have things feeding it. And the two most common ways that they get fed are we have an event stream, something like Kafka, that's just, bringing the things in, maybe, because some of these systems process 1 million or 2 million or 20 million events per second, or they could be read if they're in big blocks of data, they could be read from object storage like S3. And then on the other end, we want to visualize the data because that's what people really want to see. Is to be able to see the data, be able to see relationships. And then we have service APIs. So things that allow you to hook this up to, say, PagerDuty. If something, you see something you don't like, the API, you can do an integration with PagerDuty and alert somebody to go jump in and take care of it. So what we're now going to do is jump in and look at how we're going to run this on Kubernetes so that we can build the core of this application. So that brings us to the next part, which is bringing up ClickHouse on Kubernetes. So Kubernetes is great. I really like it, but there's a problem, which is if you run ClickHouse on Kubernetes, it's really complicated. And this is not, I think what a lot of people get kind of sidetracked on Kubernetes, that Kubernetes is inherently complex and makes applications difficult. That's not the problem. Running Kubernetes is complex, but actually putting applications on Kubernetes is not particularly complex. What you see in Kubernetes reflects the complexity of the distributed application that you're running. And the fact is that a data warehouse with multiple nodes, storage attached to them, configuration files that drive what it does, network connections, load balancers, that's something it's a complicated beast. And so as a result, you're going to have a relatively complicated setup on Kubernetes. This is something where if you just started, taking the hello world, your hello world.yaml and start to deployment and maybe a persistent volume and stateful sets, this would get really hairy really fast. And by the way, I should mention that we also have Zookeeper out there, so that's a little bit of extra complexity as well. Fortunately, in Kubernetes, the thing that has really made the difference in enabling Kubernetes to handle data and these complex applications are what are called operators. So the basic idea behind an operator is it allows you to define new entities, new types of resources inside Kubernetes, and have the operator kind of act as almost like a computer operator. That's what we used to call people that were sysadmins, that can take the specification. We call it this is ClickHouse resource definition, but it's technically called a custom resource definition. They can take a spec, look at it, and then set up all the stuff that's necessary to implement it in Kubernetes itself. So this has become a very popular model. The ClickHouse operator is one example of many. It was, to our knowledge, the first operator developed for a data warehouse, but at this point, most popular databases have at least one operator, and some of them have more. So ours is Apache 2.0. It's just a Docker container that you can install on Kubernetes and run it as a pod. So The way that you do it is the first step when you're setting stuff up is you come and just go grab the operator. And we have a GitHub site, and this wget command is how you get it. And then it's going to give you a YAML file, which is the operator definition, and you're just going to apply it using kubectl. And I'm going to assume that everybody on this call has seen kubectl and worked with it. If you haven't, it's your basic command line tool for getting anything done. So the first step then is to install the operator. The next step, because we do have a dependency on Zookeeper, is we're going to have to actually set up Zookeeper as well, just so that our cluster will work. Zookeeper is used to keep track of data when we're replicating between nodes. It handles the problem that we call distributed consensus. And again, the commands for this are fairly straightforward. One thing I want to say is in this slide, anything you see here, I'm setting this up for a developer environment. You can see I have one node. You would never do this in a real deployed system. You would actually have something a lot more robust, typically with 3 nodes. So again, fairly simple to set this up. And this is a lot of the power of Kubernetes, that you can put these things together. So at this point, rather than going deeper into how this works, I'm first going to go and actually demo just setting this stuff up, and I'm going to kick off a cluster. So let's go ahead and escape out of here. I'm going to bring up. So I've got this. I hope this is visible. I've got some screens up here. My main screen that I'm working on, I'm going to be talking to Minikube and running some scripts. So let's, for example, go ahead and install the operator, that .yaml file, and we're going to apply it. And what we're going to do is then, this runs so fast I can't really explain it, but it basically is putting this thing up in Kube system. And we see here there's now a replica set for the ClickHouse operator, actually a deployment which is driving it, and then there's a pod up here, and there it is. So we're set. We can now start to set up and control data warehouses. But first we want to put Zookeeper out there, because when our data warehouses come up, they're going to want to talk to Zookeeper. So I'm going to go ahead and install, whoops, wrong one. I'm going to go ahead and install Zookeeper. So, and that's again a very simple script, just the commands I showed. I'm going to create a namespace. So you can see this namespace just got created, called ZK. And we have Zookeeper coming up there. You can see the container is being created. If I do kubectl get pods -nzk, it's getting ready. So it should come up in just a few seconds. It needs to allocate storage. So let's try that. Give that one more second. Okay, it's up and running. So now we've got a Zookeeper node. At this point, we can go ahead and we can install the cluster. So we're going to run a file called cluster.yaml, which is our custom resource definition. I'm not going to dig into it right now, because we're going to first start this, and then we're going to go ahead and go back to the slides and study what's in there. So here we go. We're going to kick this off. And what this is going to do is we can now see that this is beginning up in the upper left-hand corner. I'm looking at the default namespace. I'm beginning to create pods. You can also see down here, I'm beginning to create persistent volume claims. So if you're new to Kubernetes, the way that you define storage is you create something called a PVC, or persistent volume claim, that asks for a certain kind of storage to be allocated. And then what that will do is Kubernetes will go and make sure, pick an appropriate driver called a storage class, and it will actually go and allocate the storage for you. In this case, because it's Minikube, we're just allocating off local disk. What we normally do in the cloud is, as I said before, we allocate off GP2 or GP3 block storage. All right, so this is up and running. And in fact, the cluster is already fully available. And so what we're going to do is switch back to the shards, or to the slides, and have a closer look at what we actually did. So here's the resource definition. It takes 2 pages, and I apologize for the code being a little bit small, but it really, the point is here, you have a very complex system, but it's described in a relatively small amount of text. So for example, we have the resource type. Looks like our arrow is pointed in the wrong place. It's actually pointed at the name, but ClickHouse installation is the resource type that the operator manages. And so that is known to Kubernetes. When it sees a YAML that has this kind in it, it's going to forward it to the operator to let it have a look and decide what to do with it. And then we have a spec, so specification, and this gives us our cluster configuration. And so, for example, we've got a cluster named Demo. Its layout is 2 shards and 1 replica each. And then it has what are called templates for pod and storage. So like, what's the specification? We'll see those in a minute, for compute and storage. And then finally, where to find Zookeeper. So this is just telling it, hey, it's off in another namespace. Here's how to find the service that accesses it. So this is very straightforward information. Doesn't require you to know anything about the mounds of configuration that have to go on under the covers to make this actually happen in the ClickHouse server, or how to deploy stuff. Looking at the second page, the templates, these are where we define what the version is, for example, of the server that we want to run. So this is a community build. It comes off the Yandex. Yandex are the people who invented ClickHouse. Comes off their Docker hub, and we're going to be running version 21.6. The volume claim template is where we talk about our storage. So we're allocating 10 gigs for each of these persistent volumes. There's also a really important setting here that I like to use. If we put retain here, it means that if we delete the cluster by accident, we won't zap the storage underneath it. This is good in case just gives you a level of protection that you don't accidentally blow your cluster away. So that's it. This is all that's necessary to set up a working data warehouse with 2 nodes talking to Zookeeper. We can start loading data into this and running queries. So yeah.
Couple of questions.
Yeah, go for it.
So how can we handle the logs in ClickHouse, and what are the monitoring tools to monitor the ClickHouse?
Great. Let me take the monitoring one first. So for monitoring tools in ClickHouse, we normally recommend Grafana. And the ClickHouse operator has a sidecar, which is a metrics called the metrics exporter. And what it does is it basically pulls out it talks to all of the nodes and basically manifests the monitoring data in the preferred Prometheus format, so that Prometheus can get to it. And then what you normally do is you set up. This comes for free. You've got the exporters. You then set up Prometheus, and then you just configure it to point to the exporters. And then what we normally use is we use Grafana to then graph the data. So that's the monitoring. What was this first part of the question?
How can we handle the logs in ClickHouse?
Oh yeah, thank you. Yeah, so that's another one. So you can basically, there's nothing magic about this right now. What you'll want to do is, we basically, you can, there's a bunch of different ways to do this. One thing that I'm ashamed to say is kind of popular is people will actually put the logs in Elasticsearch. There is unfortunately not an off-the-shelf log solution that puts them into ClickHouse, but a number of people are interested in that and working on it. But so just put anything that will tail the logs and put them in a centralized location you can use. We don't have anything that just does it magically yet. We do that, by the way, in our own cloud. We've built the infrastructure, but I'm sorry to say there isn't an open source project that does this yet.
All right. Hopefully in the future. And then we have another question. This is from one of our interns, Kunal. What is the difference between Cassandra and ClickHouse apart from the difference of row and column orientation?
So that's a good question. ClickHouse is, so ClickHouse is designed for very large scale queries in a way that Cassandra is not. So for example, if we have a query where we need to scan, say, 2 trillion rows, ClickHouse makes it relatively easy to set this up, to load the data. We understand the formats that the data typically comes from. We can read from Kafka. so we can put the data into tables, and then we can define what's called a distributed table, which is an umbrella table across it. And because ClickHouse has very highly optimized compression and very good parallelization, we can then get answers on that in less than a second. Cassandra just doesn't do this. It does not have the ability to parallelize in the way that that ClickHouse does. One of the things that Cassandra does do, which is really good, is because of the way that it uses consistent hashing. If you add nodes to Cassandra, it will auto-magically redistribute the data. And that's actually a very powerful capability. ClickHouse does not do that. With ClickHouse, you actually have to think about the distribution in advance. There are ways to do it, but there are essentially things that have to be thought out by your application. So if you add nodes to increase capacity, it doesn't magically take some of the data and put it on the way that Cassandra does. So that's actually a fairly major difference, and one that we're working on, and we'd like to have ClickHouse have the same capability, but for now, give Cassandra the nose on that.
Okay, perfect.
Okay, so what did we create? When we ran that, it came up so fast that we saw it. So we've basically got this little beast here. It's got a red pod, that's shard 1. It's got a blue pod, that's another shard. We can make tables on them, on each of them, and ClickHouse will understand that, hey, they're different shards. When we have to query them, we'll have to look at both of them. It's on ClickHouse version 21.6, and it's pointed at Zookeeper. So this is actually a little bit puny. There's no extra copies of data. Like if this pod got lost somehow, this red one, we'd be in trouble. So one thing we might want to do is, let me, yeah, so this is what we created. I'll get to how we address the puniness in a second. So just some things that we want to do. We can now go ahead and start working with this. And because this is Minikube and I'm not doing anything special, you know, I might sail out there, have a quick look. One of the first things you want to do whenever you run data is you've built a cluster, go out and see if you've really got PVs, like persistent volumes. Did it really allocate storage, and is it the storage you expected? This is just, if you run data, you got to be paranoid. So, and the reason for this is it's very easy to get this wrong. I did a whole talk on this at Kubernetes at one of the KubeCon conferences about 5 ways to lose your data, and so one of them is not really doing persistent volumes. So I always go out, check that they're there, check the claims, make sure that they look good. Second thing is you can go and access ClickHouse. With ClickHouse, it's really easy to get in with kubectl exec. I'm just going to jump into, this is a command to jump into one of my pods and then run ClickHouse client, which is the command line client. This is a great way to get in and look at it. If you want to talk to it from outside, I'm just using, you know, sort of a basic Minikube setup, and I just do port forwarding, which enables then makes the service visible to the outside world on port 9000, and I can load data from off my machine where this Minikube is running. So, you know, once we've done this, we might want to make it better. So to get the real flavor of a production deployment, we'd probably want to have multiple replicas. That's how we typically run. Replicas help us if we lose one. They also give us the ability to spread the queries out. So we can have, if we have a query or a lot of queries, they can run on different replicas. So it extends the number of, the amount of resources we have to process queries. We can also change the version. These are 2 common things that we might want to do. So what I'm going to show you is we've created the cluster. I'm going to go ahead and add replicas, and I'll show you how to do this. Because the ClickHouse, what happens when, when we read this resource definition, if I go ahead and apply it again, the ClickHouse operator will receive it, and then what it's going to do is it's going to compare what's in the resource definition now compared to what it saw before and what resources are out on the system. And then what it'll do is it'll form a plan to go ahead and make appropriate changes out on Kubernetes so that the deployed cluster looks like that specification. And rather than explaining it further, it's just simpler to show it in action. So here it is. All right, so I've got actually a couple versions of this cluster. Let's see if I've got the command handy. There it is. So I have cluster.yaml. That was the original cluster definition. It had one replica. I've got cluster2.yaml. The only difference between them is I've changed the replica count. So I'm now going to make it 2 replicas. And what I'm going to do is I'm just going to run kubectl -f and go ahead, whoops, apply -f, sorry. So here it is, give the file, off it goes. And what we should see is this will get processed, and in a second here, we will see new pods starting to come up. We'll see new storage claims being created down below, because and they're created one at a time. So the operator is pretty smart. It wants to change the system in a systematic way. For example, if we were doing an upgrade or version, it would again just do the pods one at a time, because we don't want to take things out of service while this is going on. So there we go. We've now got, in a second, we'll have both new pods up and running, and then we'll have what we call a 2x2 cluster, 2 replicas, 2 shards. And there it is. So there's many more things that we can do, but I don't want to, you can try them out yourself. We can load data into it. We can try blowing away the cluster, confirm that the storage stays there. There's all kinds of fun things that we can do, but I'll let you try that yourself. Let's talk a little bit then about how to turn this into a full application. And this gets really hairy really fast. But I'm just going to give you some hints about how you can do this and where to go next once you've got this core. So real applications are complicated. This is one from some friends of ours at Mux. They do video streaming. For example, they did the video streaming on the US Super Bowl last year or last season. And what they do is, the cool thing that they do with their analytics is they enable people. So for example, the television companies that are running the Super Bowl are streaming it out, and Mux gives them the ability to look at the state of the streams in real time. So they can see where, like, are there locations where they don't have sufficient capacity? Are they having rebuffering issues? Anything else, they can see it in real time and actually diagnose and fix problems. So they have a bunch of data that gets fed into this, sort of from different sources. They put it into Kafka. It gets loaded into ClickHouse and put into tables, and then it shows up in various places where users can get at it. So for example, there's a console with really awesome graphics that you can do that sort of slicing and dicing I described with Google Analytics. You can do that inside Mux. They have APIs so that people can pull it out, and then they have different kinds of exports. So for example, alerts to tell somebody, hey, there's something you really need to look at. Here's where to go. So this is what the application looks like. You can actually build this whole thing in Kubernetes. There's a couple of capabilities inside ClickHouse that are particularly relevant here. You can run Kafka in Kubernetes. I'm not going to show how to do that, but the key thing is, once you've got it up and running, like Zookeeper, ClickHouse can talk to it and actually read the data directly off topics. So this diagram just shows the stream or the path that the messages take. You have a topic, which is basically a queue in Kafka. It can be partitioned, which means that there are many sort of distinct shards, if you will, that you can read from. There's something called a Kafka table engine inside ClickHouse. It takes the topic, makes it look like a table that you can do selects off, and by selecting it, you read messages. There's a thing called a materialized view, which will do that automatically at intervals, and then it puts it into a source table where you can actually run queries on it. This whole chain here can happen in a few seconds. So basically, you can put data into Kafka, and it will hit ClickHouse source data tables within a second or two, without you having to have like a complex pipeline or anything like that. Another interesting thing that ClickHouse can do is it can read from S3. So for Kafka and sort of its peers, we'll talk about them in a second, are great for delivering events quickly at scale. But for bulk events, S3 and object storage in general is the way you typically go about it. Again, ClickHouse can read directly from it. This is an example of inserting into a table from a bunch of S3 files that are in Parquet format. So this is just one example, but there are many other ways that you can, many other formats that are supported. So, and ClickHouse will load these in parallel, so it's very quick. So there's also a bunch of BI tools. This is relevant because you may want to do custom analytics the way Mux did, but a lot of times it's just good enough to hook up BI tools and show people what you've got. So for example, 3 BI tools that work really well with ClickHouse are Tableau. Actually, that's a recent thing. We just published a connector for it, so that makes it work a lot better. There's Superset that we've done a fair amount of work with and collaborated with the Superset developers. And then there's Grafana. So, and just if you're wondering which one to pick, Tableau and Superset are really great as business, for sort of business users and analysts. Tableau is more for operational analytics and requires programming skills to set up the dashboards. So they all have different strengths, but they all work really well with ClickHouse. And in particular, Grafana works great on Kubernetes. Superset is can also be run on Kubernetes. I haven't personally done it, but I know that the preset folks do this as part of their cloud offering, so it runs very, very well there. Tableau, of course, is sort of a different beast and it's proprietary. So what you then get is you have these different options for implementing these in-app analytics that can all be done inside Kubernetes. And so for the event stream, here's just 3 things. Kafka I've talked about. There's also Pulsar, Apache Pulsar, which is fairly popular. Red Panda, which is a Kafka, sort of lookalike, but is focused on being even faster. For object storage, there's S3, so Amazon S3, or then anything compatible. One storage, if you're running on-prem, MinIO is something that's definitely worth looking at. It has an S3 compatible API. It's really, really fast. We benchmarked it, and it can be way faster than Amazon S3 because it runs locally and you have more control of the hardware. ClickHouse is in the center. We showed how to run that. And then for visualization and service APIs, you either use BI tools or you roll your own the way Mux did. They used JavaScript, so it's relatively easy to, for something like TypeScript or JavaScript to connect to ClickHouse and load data, and then you can put it into one of your own graphics. And then for service APIs, people either roll their own, using REST or GraphQL, which they implement however they prefer to do that, like Node with generating the APIs off Swagger or something like that. Or there's emerging tools like Cube.js, which is an interesting project that is JavaScript based. It runs in Node. It basically builds data cubes for you, which your applications can then connect to and add their own graphics. So that's an interesting option as well. All of this stuff can be set up in Kubernetes and allow you to build an application. So the final slide really in the detail is like, hey, what didn't we talk about? I'm making this seem, it's starting to look a little complex, but you could think, hey, this is pretty easy. The fact is that you can set this stuff up on a desktop. In fact, you can set it up using Docker Compose and you can do your development. But when you actually come to deploying these systems, they do get complex, and there's no way around it. It's just the nature of the beast. So for example, one of the issues is that the different components I showed, not all of them have nice operators. Operators are very common in databases, but as you move to other things, for example, Superset, as far as I know, does not have an operator. I hope they will get one, but that's an example of where you have to do a little bit of thinking about how to deploy it. There's obviously questions about how you do your CI/CD, how do you get these things rolled out and actually deployed and upgraded and things like that. And then there's actually the details of the production deployment, everything from managing Kubernetes itself all the way to security considerations. And in fact, if you're looking at this, one of the things you might be asking is, is this complexity something that pays for itself? I think that the simple answer for that is, of course, it depends. If you're just doing an in-house application and you want to link these things together and you want to get it done quickly, you're probably better off just using cloud services. So for example, use the Altinity.cloud service, go to Confluent and let them run Kafka for you, go to Preset, let them run Superset for you. You can link these things up in the cloud and they work. for a one-off application. But if you run a software as a service, this actually turns out to be a really great way to set things up, because it allows you to have control over the components in the application. And the fact that there's more complexity is more than that. You pay for that, but then you get the benefits of having complete control of the environment, being able to control scaling, being able to isolate tenants in good ways, being able to port, sort of, for example, be able to run on GCP as well as Amazon, as well as on-prem. These are all really big benefits that you can get through Kubernetes. And Kubernetes resource management is outstanding. So also the fact that you can run many, many tenants on on Kubernetes. If you need to scale it, just add more nodes, and Kubernetes will have more capacity. So this is a good reason why you'd want to go this way. So learning more, here's some references. Bart, I'll post these slides over to you when I'm done. These will actually be a PDF link, but there's just a bunch of ways to find out about this. Ranging from the, like going and look at the operator site. ClickHouse for an open source project has a really good documentation. I mean, it's all community driven, but it's quite good. We do blogs, we do webinars like this one, and we write documentation. So and then other people are writing blogs. There's hundreds of people who actually participate direct, like do pull requests on the project, and there's thousands of people who participate in other ways. So it's a really, really big project, and there's just a lot of stuff out there. And that's it. Bart, thank you very much for setting up this talk. I hope people have enjoyed it, and I'm here to hang out and
thank you very much. Yeah, thank you very much for delivering it. I think there is a lot of stuff there, but very well explained. We have, because it was explained in terms of our audience, we've got everything from college students to seasoned practitioners, and everyone's chiming in. So it's good to see. One of the things that I wanted to mention is something that I saw tweeted the other day by one of our other community members, who's a big Postgres fan and has done a hands-on lab with us and some talks about Postgres and Kubernetes. But he tweeted about how, let's see, I'm trying to find my own thing. He tweeted today and said that CRDs are Kubernetes' very best feature. Prove me wrong. I'd like to get your feedback on that.
Well, I can't prove him wrong. They enable you to run databases. That's like as simple as that. And take Postgres, like what I can do is I can have an operator that just sets up, primary, secondary. I have my core Postgres. I have primary, secondary replication. I can do vertical scaling. Like let me give you an example. I didn't show this, but with Kubernetes manages block storage really well. And so, for example, when we're running out on Amazon, we will go ahead and enable vertical scaling, where we'll just replace the pod with a bigger one. It reconnects to the block storage, and bang, you're up and running. This can happen. You can literally, I mean, it depends on how long your database takes to warm up and actually be fast, but this is really simple to do. And operators basically encapsulate this logic, and they encapsulate the logic to do upgrades in a way that don't bring your applications down. They are one of the best features of Kubernetes. And I think this is something that where with the operators, Kubernetes went for something that was, hey, it's good for websites and, sort of stateless things, as you were saying at the beginning. You can now manage data and complex applications on it. It's a really, really great feature.
Okay. Just taking that a little bit further, what would your second favorite feature be? Second best?
Of Kubernetes, I think the resource management overall is because if you think about what you're trying to do particularly in multi-tenant systems, your challenge is basically bin packing. It's sort of, how do I get as many tenants, as many people's requirements satisfied most efficiently on the available compute, storage, and network that's available to me. And Kubernetes does this very, very well. So, and what it means is that because we have resource management, and we can, for example, move pods around, and take care of the, sort of distribution of processing to the appropriate size nodes. I can increase my capacity linearly simply by adding nodes. I can also take them away, and Kubernetes is smart enough to move things to other locations. I think for me, that's the other part. And then beyond that, in general, I think people really underestimate how complicated distributed systems are.
Mhm.
And Kubernetes just has all these features like secrets, for example, that just allow you to deal with these kind of gnarly and boring and ugly problems, like getting a certificate out to every node that, or to every service that needs it. This is just something Kubernetes handles very well. And so yeah, that's another thing. And moreover, it does it portably. I can develop this. I can develop this on Minikube. I can push it into something like Amazon EKS, and it basically works there. It's pretty portable.
Good. We got one thing right here, more on the side of feedback as opposed to just a question. This is from Paulo saying, Robert, I love ClickHouse, love it for site. I would like to test or talk about ClickHouse vs Trino in reading data from S3 or other DBS. And say used on Metabase and runs smooth. So just a nice comment.
Yeah. So is there a question on that?
No, just
Yeah.
love the feedback. You
Yeah,
got
yeah.
yeah.
So yeah. Hey, Metabase, I'm glad you mentioned that. There is apparently a really good driver. We have not looked at it. We've been trying to talk to the Metabase folks, but yeah, that's one that's not on our list. But definitely check it out. It's written in Clojure, so I'm not a Clojure person. So I've talked to people who use it. They really like it. So I'm glad he likes it. I love ClickHouse. It's my favorite database.
No, I can tell you definitely have a lot of knowledge. But it's nice to see as well too that it's always good to see speakers that are willing to say, other databases have some features that this one doesn't have. In particular, as you mentioned with Cassandra, sometimes it's a use case thing, it's a personal experience thing, a lot of
Yeah,
factors.
absolutely. And so two things that ClickHouse doesn't handle well: very small, highly concurrent queries. So you got an e-commerce site, you got a million people, sort of pecking away at it. You do not want to run that. You do not want to have like the baskets or the session information stuck in ClickHouse. You want that in Redis, you want that in MySQL, something like that. The other thing it doesn't have is a full transaction model. So fully ACID transactions, there are things where you just need stuff to be consistent, isolated, durable. ClickHouse is not your database. It's designed to do data which is basically write only. There are ways to simulate reads, but that's not the sweet spot. It's like pile boatloads of data into it and read it really fast. That's where ClickHouse shines.
Good. All right, we still got a couple more questions. So and if we go a little bit over time, Robert, if you've got a few extra minutes,
No problem.
I'm sure our audience would appreciate it. So what is the storage type recommended for ClickHouse running on Kubernetes?
Yeah, right now we're using GP2 on Amazon. I think that that's a dual. There's two questions there, because actually, what kind of storage do you mean? If you mean block storage, we're generally using network attached storage, but for block storage, you can also run with local storage. And one of the advantages there is that, of course, if you've got NVMe SSD, that gives you like just brilliant performance. What you're doing, though, of course, is you are now, if you're using local storage, you're pinning the pod to that node, and that's in general. We actually do this when we're running in Kubernetes in the cloud. We actually do allocate a VM per pod, and so if we're vertically scaling the pod, we reallocate the VM, but it's on network, it's on block storage. Now, if you do that with local storage, you'll lose your storage. So you don't have so being pinned means that if you lose that pod for any reason, it's going to be gone. You can't vertically scale it. So your choice, but people make the choice both ways. Then the second thing is like, what kind of object storage do you want to use? Object storage is now something that's emerging in ClickHouse as a viable way to store the long tail data. You can use Amazon S3 or other, like S3 compatible storage types. MinIO is one of them. We've tested it in Kubernetes. The performance is outstanding. So, if you're running on-prem, for example, or in, something that you otherwise are doing self-managed, that's something where you might want to look at that as well.
Okay. Another question: how do we move data from one ClickHouse operator in one Kubernetes cluster to another?
That's a great question. There's a number of ways that you can do it. The simplest thing is to copy parts. Let me just give you a list. You could do a backup and a restore That's one way you can do it. Use ClickHouse Backup for that. You can actually manually copy parts off the file system, but it's kind of hard because you have to get in and rsync them. You can also, what we typically do is just read them straight out of, you can select parts in native format or data in native format straight out of ClickHouse and then just load it into the other one. That's probably the easiest way to do it. There's also something called the, what's it, a ClickHouse copier, which is depends on Zookeeper and knows how to copy data between clusters. So those are different options that you can use. And oh, actually, one final thing I shouldn't, because this is an obvious one. You can replicate. You can set up more replicas, let the data replicate onto them, and then just disconnect them. So that's another way of splitting a cluster if you needed to move it.
All right. Next question. Is there any document for taking ClickHouse backup as a sidecar?
No, there's not. And we do have a blog article on using ClickHouse Backup, but I've got a note here, and this is probably the same person who asked about it. We need to get that out there so that y'all can know how that works. I'm going to see if we can't put together a blog article on that. If you're interested, feel free to send us, let's see, I didn't say, you can come to the website, contact us if you want to follow up on that, info@altinity.com. But yeah, backup is like one of my hot button topics. So I'd be glad to talk about that.
Good. I just posted that email in the chat if people want to get in
touch. Oh,
okay,
great. Let me just pull that real quick to make sure I've got it.
Okay, and then the another question: how many requests come from which client, like Tableau, Kafka Consumer, or manual query for monitoring?
Oh, how okay, so how many requests? What is the question here? Let me define what I think could be meant here. Is like how much of each of these is putting load on the system.
Yeah.
Generally speaking, okay, that's now again putting in this. So it depends. So here's the thing. So with Kafka, one of the things about this is another difference about ClickHouse and data warehouses in general. When you're loading from something like Kafka, you don't want to load every row individually. That will kill your data warehouse, because it really, what it wants to do is arrange the data in very large blocks. It'll then spend a bunch of time doing what we call merging to join the data into blocks that can be read quickly and have high compression. So what you'll do is you'll be pulling the data in from Kafka, say every second or so, or whenever you get 100,000 rows, something depends on your ingest rate. But so you'll have these coming along, ticking over on tables, maybe every second or two. You will then have queries coming in from from the visualization side. There is an important issue there, which is if you're using Grafana, what Grafana does when you fill out a dashboard, they're beautiful, but Grafana has no caching. So what that means is if you have a lot of people using the same Grafana dashboard, every time they hit that dashboard, they all run these queries on ClickHouse, even though they could be exactly the same queries looking at the same data. Most people who have if you have a lot of people looking at it from the visual, from the user side, you're probably going to want to put some caching in there. Superset does this natively. Cube.js is another that I mentioned, does this natively, or you can build it yourself. You're going to put something halfway in between that's going to enable those folks to get in, but not have to hit ClickHouse every single time, because they're going to consume resources, and in some cases, it's going to be slow.
All right. Last but not least, this is a wonderful talk in many senses. You are the CEO of Altinity, and so we got a question. Can you just give us a little bit more info about Altinity briefly?
Sure. We're the enterprise provider for ClickHouse. So we serve the Western European and American markets primarily, although we have customers all over the world at this point. We have about 130. And our goal is to do everything that's necessary, provide everything that's necessary to allow you to build analytic applications on ClickHouse quickly, get them deployed, operate them with the lowest possible risk and cost. So concretely, we do everything from training your team up front, giving you guidance on POCs, to 24/7 support, to running it for you in the cloud.
All right.
So if you want to get something, and basically the goal is, we're basically, people building these systems are devs. We want to make it possible for devs not just to create them, but also deploy and operate them. That's the part we take care of and help you guys focus on building something that's valuable to your customers.
Very, very good. Excellent summary. Does Altinity hiring right now by any chance?
Absolutely. Yeah. If you heard this and you thought either I'm messing it up, you could do it better, or you just like it, check us out. Yeah, we're hiring really fast. We're looking for everybody from cloud to ClickHouse experts. We have, and we're sort of, we build features in ClickHouse. We support ClickHouse, and this is not your grandpa's support. These are people who are what I call ClickHouse super users. They do side projects. They're also big puzzle solvers. And then finally, we have the cloud folks. So we're also looking for a dev advocate. That's one I want to highlight. Somebody who loves doing development, which kind of like I'm more of a dev person than database internals. I'm looking for somebody that loves that and wants to tell people about it.
Very, very good. So if you want to work with Robert, you know where to go. Check that out. We'll also put those links in our Slack. Speaking of Slack, we can always continue the conversation there. We had some great questions today. Definitely worth taking some few extra minutes. Robert, I will be getting in touch with you to do some kind of a deep dive on Roman history at some point and how we can relate that to tech.
Excellent.
I know we can.
Yeah.
Thank you very much, everyone, for joining. As usual, subscribe on YouTube. Check us out on LinkedIn and Twitter. We'll be joining you next week for 2 meetups. One with someone in China who'll be talking to us about some Apache technologies. And then we'll be joined by Keith McCullen from CockroachDB, who will be doing a deep dive on certifications and all the preparation necessary to do that. So anyway, Robert, thank you very much for joining us today, and hope to see you soon.
Yeah, thank you, Bart. It's been